Good morning, ladies and gentlemen. Today's lesson is self-guided, with meaning that you are going to listen/watch these videos and fulfill the notes yourself. Miss King and I are here for logistical issues to support you, but the actual learning is through videos. So today's learning is about surface area, specifically total and lateral surface area. So then the question becomes, well, what is total surface area? Which is a great question. Total surface area is the area of the outside of any figure. Recently, we've been learning about volume, which is filling up the inside. So if we had a cylinder, how much of Dr. Pepper would it take to fill up the cylinder? Okay, what is the space of the inside, the 3D space? Surface area is the 2D space on the outside. Okay, so volume was inside, surface area is on the outside. You could almost think of it like this picture down here, like a Christmas gift. How much paper would it take to wrap the area of the outside of each of these three figures? Because these are the three shapes you're going to see in surface area, which will be covered in the videos to follow. But total surface area, our definition is going to be covering the entire outside of a figure. Covering the entire outside of a figure. In parentheses, I just want you guys to know mathematically, that means both bases and sides. As an example on this one here, and I'm going to use the scribble key so you know what I'm talking about, that would mean the top of the cylinder, that would mean the bottom of the cylinder, but that would also mean the sides of the cylinder all the way around, okay? And I'm going to change that to red just so it's a little more obvious. So it's covering all of it. That is total surface area. And we could do the same with rectangular prisms and triangular prisms. On the next side, it says, what is lateral surface area? Well, lateral surface area, good news for you. And again, I'm going to use my scribble key so that's easier for you to see. Lateral surface area is just the area of the sides. That means no bases, just left to right per se. Okay, just the sides. So you could almost think of it like the outside of a vegetable can or a can of peas or green beans, or maybe like if you get refried beans and you don't want to make them yourself, you just want them made already. It's a can of beans. So it's the side, okay? And we could do the same thing on a rectangular prism, like an aquarium. Even if you have fish, maybe you have you put like a little cool wallpaper around it or design, so you make the fish feel like he's back in the sea, even though he's not or she's not. That's kind of the idea of lateral surface area. It is the side of any three-dimensional figure. And of course, the same thing for triangular prisms. It is the side, no bases. And you can usually figure out which are the bases by looking at which ones are parallel congruent. So this triangle here in the front and the back, those would be the bases. And these rectangles on the side would be our sides for lateral surface area. All right, but that'll make more sense as we get more practice with it. So our definition, formally, that we're going to use in math, okay? So I should say informally, is covering just the sides of a figure. And in parentheses, I'm going to put no bases. Make sure that you type all of these notes in your slide because you will be submitting it at the end of class today.